All right. Good afternoon, everyone. My name is Amanda Speciali, and I work in NOAA's Climate Program Office supporting the Climate and Societal Interaction Division's Adaptation Sciences Program. I'm excited to facilitate this webinar today as part of NOAA's Science Seminar Series. And today's topic is using visualization science to improve expert and public understanding of probabilistic temperature and precipitation outlooks, which will be presented by Dr. Melissa Kenny, Dr. Michael Gerst, and John Gottschalk. So I'll go ahead and briefly introduce our speakers to you. So Dr. Melissa Kenny is Director of Research at the University of Minnesota's Institute on the Environment and an environmental decision scientist who seeks to understand and to improve the processes of engagement and tools such as indicators that aid environmental decisions both in the public and private sectors. Our next speaker is Dr. Michael Gerst. He is an associate research professor at the Earth System Science Interdisciplinary Center at the University of Maryland, who focuses on the science of producing and using multidisciplinary information for decision-making and communication. And finally, we have John Gottschalk, who is the chief of the Operational Prediction Branch at the NOAA Climate Prediction Center, who is responsible for the Climate Outlook products. Lastly, I wanted to mention that we will take some time at the end of this presentation for questions, so please submit any questions you may have in the questions box. And additionally, if you're having any technical issues, please use the questions box as well, and I will try my best to help you troubleshoot. So thank you all very much for tuning in today, and with that, I will pass it over to our speakers.
Good afternoon or good morning, depending on where you're calling in from. It's so great to see you all here today. My name is Melissa Kenny, and I'm really excited to present research that we've been doing on looking at how we can improve visual communication to both expert and public audiences. We're going to use, one of our examples will be the probabilistic temperature and precipitation outlooks, which had an exciting operational change earlier this week. But before we jump in, the first thing I wanted to do was just tell you a little bit about the work that Mike Gerst and I lead. We do research that is multidisciplinary social science. We're working to increase the use of evidence in a whole range of fields, from climate adaptation to interdependent infrastructure decisions. More or less, like if it's a complex environmental problem where better information could help to make better choices, that's our sweet spot. And we do that by both improving the processes of engagement between scientists and non-scientists and academics and other experts in a wide range of fields, as well as the tools like indicators, forecast outlooks that help people and organizations to make smarter choices. So one of the things that really sort of piqued our interest was the amount of play that visual graphics like the temperature and precipitation outlooks get within the public sphere. We use them a lot to understand and make decisions. And one thing that was really striking was that there's a lot of scientists who make decisions about the best way to present these to the public, given their intuition and maybe feedback that's provided by particular users. And one thing that we learned was that many of the producers of these graphics don't necessarily understand that intuition and feedback is not always a good predictor of whether a visualization is effective and understandable. We actually have a whole range of tools in our toolkit that help us to rethink that strategy. So a few examples of best practices that we've learned over the years, given cognitive psychology and cognitive principles. So first is color is super powerful. So you want to use it really strategically because color is easier to distinguish than shape. The second is if you're trying to present two things, remembering the power of color, part of what we want to do is group those together so that the visual representation matches the number of dimensions of data that you're trying to present. This indicates that you're trying to present 4 things when you actually are trying to potentially present 2. And then finally, changes in hue usually give an indication of some kind of large shift that is happening. So you want to be really thoughtful about when you change intensity versus hue, because it really has a different indication of what information you're sharing. And that means that rainbow color palettes are really the best choice for graphics that are going out to the public. One of the other things is that we've learned from text-based communication that scientists and members of the public, or even scientists who are not expert in that particular domain, expect their information presented in different ways. And we would argue the same is true for visual communication. Usually when we're presenting scientific information and we're developing a peer-reviewed article, for example, those journal articles are designed so that we present the broad range of the fields, and we kind of provide supporting details and then narrow down into sort of the punchline and the results and conclusion. We basically want to flip that model when we're working with the public. We want to give them the bottom line or the key message right up front, and then be able to layer details visually or through text-based communication as they're looking to seek additional clarification information. So the overarching question that we had shaping the portfolio of work that we're going to present today is whether using visualization design principles would improve communication of scientific information to non-technical users. And one of the things that we did was, instead of taking a singular case study-based approach, what we sought to do was develop a generalized methodology that could be applied for developing an empirical way of testing whether graphics actually performed better. And that general method is done in collaboration with the producers of the data product. And the first thing that we do is we interview experts and users. So experts is used very broadly, not just to indicate scientists, but to indicate anyone who has expertise in how they would use a graphic and interpret a graphic like this. So we talk to them about the goals, different audiences they might be trying to reach, and different decisions and uses, with the weight of the questions varying depending on the person. The second thing we do is we use a typology to diagnose the challenges with the existing graphic, or best practices if we get to design from the beginning, but we're usually working with existing data products. And that gives us a baseline that we can then combine both the interviews of expectation as well as what has been shown to perform well or not so well, so that then we can go into control versus treatment tests, where we take the original graphic and test it up against one or more modifications of that graphic designed to better serve user needs. And that's the basic formula that we use to examine these graphics. So what we want to do now is we want to share with you 3 case studies of graphics that we've worked on with the U.S. Global Change Research Program's National Climate Assessment graphics, work we've done with the USGS water mission on the water watches, and then thirdly, NOAA's temperature and precipitation outlook. So at this point, what I'd like to do is turn things over to my colleague, Mike Gerst, who's going to share these case studies.
Great, thank you, Melissa. So the first case study that we're going to talk about was looking at the U.S. Global Change Research Program indicators, as well as some from the National Climate Assessment. And these are indicators or visualizations that are meant to be public-facing, which is one important point that we'll keep coming back to. And the way this was done is that each original was diagnosed for potential problems, and then we tested it against 3 modifications. And for the sake of brevity, what I'm going to show now is just the eventual modification that gave the best result. Next slide, thank you. So one of the first ones we looked at is the annual greenhouse gas index, which is this plot on the left side of the screen. And the main key message for this graph, as designated by the originators of the report and website it was in, was that the greenhouse gas index had gone up 34%. That was the main message, nothing about fractions of greenhouse gases or anything like that. And so what we said is that, okay, since that's the main message, a lot of these other factors shown here, such as having a stacked bar graph and two axes, is maybe extra information. And so what we did is we tested the original against this much simplified graph that's shown on the right. And we found a fairly large difference in the percentage of people who were able to identify the key message of the graph correctly. And so this was at least, I believe it was about a 16 or 17% increase in percentage that got it correctly. Next slide. So similarly, this is another global change indicator visualization. So this is looking at annual heating and cooling degree days in the US. And here, again, the main message was essentially that one of those trends is going up and one of them is going down. And the diagnosis was that putting these on a combined chart, just for the sake perhaps of saving space, or maybe hypothesizing that people can see them better superimposed together, we hypothesized that that was actually not true, that if you separated these into two different graphs, then people would be able to identify the trend better. And as you can see in the bar graph below, that was definitely the case. Next slide, please. And then finally, this is perhaps the most dramatic result of this sort of work, is a US spatial and temporal temperature change chart from the National Climate Assessment. And so here again, the main key message for this visualization was that overall across the US, temperature has gone up, and that one region, namely New England, Mid-Atlantic, had the highest level of change, and that one region, the Southeast, had the lowest level of change. And so given that this is a fairly simple key message that doesn't require high resolution spatial maps or time series plots, we hypothesized that removing these and simplifying by region or aggregating by region would lead to a large improvement in the general public being able to identify the point of the graph. And as you can see below, this is one of the more dramatic results. I think only a third of people who responded to our survey were able to identify the message of the original graphic, and it's approaching about 75% once you use this much more simplified graphic. And so the take-home lesson from this portion or this particular use study, you can switch to the next slide, please, is that especially for general public-facing images where you're not expecting people to sit with an image for a long time and explore it, is just to visualize the main story and nothing more. Anything else is likely to confuse people or lead people to focus on factors that are not important for what you want them to learn. Next slide, please. So the next example I'm going to talk about was a project with the US Geologic Survey with their WaterWatch decision support products. So this is a slightly different product in the sense that these are decision support products with probably a smaller public-facing element, although there's a desire for it to be more public-facing. And so the Geologic Survey was going through a renewal period of this product, and we're interested in a few key targeted questions of what sort of changes might be beneficial, given that changes can be controversial to a large user audience that cares a lot about the product that they produce. And so we specifically looked at the effect of changing the color maps and whether prompting users with a legend improved understanding and efficiency of use of the graphic. So if you go to the next slide, please. And so what does this look like? The main change that we're looking at here is changing from the original, which is a rainbow color map where normal or near normal is this sort of bright green color. Above normal, stream flows are the blue scale with black as an extreme, and below normal is a sort of red maroon color map to something that we hope was a bit more intuitive, where normal is this sort of whitish gray, blue again is above normal but without a black extreme, and then brown is below normal. Next slide, please. And so one of the first questions we asked ourselves is that, if you just ask people to look at those colors, a rainbow scale or a brown-blue color scale, how intuitive are they for this sort of task? And so for one of the first questions we asked, we just showed people the colors and asked them to arrange them from most above normal to most below normal. And what we found is that very little to no one can do that with a rainbow color scheme, largely because using green as a middle point and black as an extreme point was very confusing for people. In contrast, for a brown-blue color scheme, a third of people were able to order all of them, and a significant number, about a third, were able to number 3 of them. And that was partially from confusion of it being an anomaly and using white as a center color. Next slide, please. And so the questions we asked here is we asked people to go through a variety of tasks that were targeted at how well they understood the extremes, so the high and low, as well as how well they understood the deviation from normal. And so I'm highlighting the extreme questions here. And so for moving from this sort of royal blue to black to the blue color scheme, we found that a color change would significantly improve the understanding, but not the amount of time it takes people to correctly answer something. In that case, only prompting people with a legend so that they actually know what they're looking at improves the amount of time that they're spending on it, which to some extent makes sense because they know what they're looking for. For the low extremes, going from the sort of red maroon to the brown color scale, here we found the color map didn't make much of a difference, but the legend improved both the understanding and the amount of time that people were spending on it. And from the open-ended comments we got, we found that some people had trouble discerning the different shades of the brown color scale. So it's I guess maybe an important caveat, attention to detail needs to be made when changing these things to make sure that by fixing one problem, you're perhaps not creating a new one. Next slide. And then finally, in looking at comparing normal to the next category over, either above or below on each side, one of the things we hypothesized was that it's, and this is perhaps obvious when you see the map, it's very hard to compare this sort of bright green and turquoise blue, especially when there's a bunch of dots scattered around one another. And so moving that to comparing a light blue to white, that dramatically improved understanding and reduced the amount of time it took people. For comparing the orange and green, we didn't expect a whole lot of difference in understanding, but we did see an improvement in adding a legend and reducing the amount of time it took people. The next slide, please. And sort of the most surprising thing that I think came out of this is we asked people a lot of subjective outcome questions. And this is basically like, which one is more appealing, which do you prefer, which do you trust more, that sort of thing. And what we universally found is that for no matter how you phrase that question, people either very much strictly prefer the rainbow map or they're about indifferent. In none of these did a majority strictly prefer the brown-blue color map. So next slide. And that leads to one of the, I think, the bigger lessons learned from this use case is that historically, feedback is often given by subjective feedback, either asking people how much they like something, rating it by stars, etc. And what this shows is that it can be highly misleading in the sense that people might like something, but they might not be able to use it better than an informed alternative design. Next slide. And then finally, we're gonna, this last case is the the work we did with the NOAA Climate Prediction Center's temperature and precipitation outlooks, which is an example you see here on the left. Next slide. And for reference, this is the main publication that came out of this. And after I finish talking, John will give you all a bit more detail about the implementation process of this. Next slide. And so when we looked at these, Melissa earlier talked about the diagnosis process. I'm going to give a bit, in this use case, I'm going to give a bit more detail about what that means. So in this case, there were a few things that kind of jumped out to us. One was that the Canada and the US were both using the same, what we call visual variable, in this case, color, and more specifically, the color white. And that's sort of a classic example in the literature of an ambiguity in color choice that almost always causes confusion. Next slide. And the second was that across different products, white was used for different types of categories. So in one, it's normal, and another, it's equal chances. And also that being matched with the color of no data in Canada, we hypothesized would make it confusing for some people, especially the general public, to understand what it meant. Next slide. And these next few are more just sort of decluttering, cleaning up the visualization sort of comments. So we hypothesized that dashed lines in terms of the contours in the background might confuse people. The lettering overlapped with state borders, and some of the text might be too small for people to see. Next slide. And also in this case where we have a legend that doesn't necessarily match what's going to be shown on the map itself. In this case, there's not really an opportunity for a normal category, or that if it does exist, the level of granularity and detail doesn't match what's going to be shown. So oftentimes it leads people to think that they're missing something if they don't see it. Next slide. And then finally, again, the contour lines lead to problems with being able to clearly see things and with clutter. Next slide. And so taking all of those together and working with the CPC team, this was the prototype that we came up with that we then tested along with two other alternatives and the original. And we found as there are significant improvements in understanding of the near normal and equal chances categories. And this was especially dramatic in asking people what the white and grayscale regions of this map meant. There was much less confusion that it meant no data or some other sort of thing that was incorrect. Other than focusing specifically on the US, one of the biggest changes here was removing a lot of the clutter in the chart, as well as being a bit more clear about what the probability categories meant. And now I'll let, instead of telling you what the lesson learned is, I'll let John give you all a bit more detail about what we learned.
Okay, thank you very much, Melissa and Michael. I'm going to go ahead and go to the next slide. I'll be talking about the operationalization of the outlooks and some of the details that Mike just went through in his last case study. So we kind of be talking about making the recommendations operational within the Weather Service. And I want to make sure I thank my colleagues at CPC, Scott Handel and Adam Hartman, and also Matt Rosencrans, for working on some of the technical details in the backside with respect to coding and regular information to make this happen. So we go to the next slide. So with respect to that, I wanted to give just a brief review actually of the general findings, and Mike has already provided some, but the collaboration between CPC and the University of Minnesota now and the University of Maryland staff provided generally two major recommendations from the project that we worked on with respect to this. And one related to just the challenges that we faced for several years at CPC with respect to understanding our outlooks. What exactly do they mean? How can we best use them for our decisions moving forward? And this dealt with a lot of things such as just clutter, clarity with respect to so much text, unclear text, things like this, the legend design, and so on. And what they proposed for us was will produce the greatest improvement with respect to the understandability challenges in their recommended treatment. And so that was one recommendation that we wanted to apply to our outlooks. And the second one was it's a longer term horizon recommendation that we're working on now, which was to provide consistency across the entire temperature and precipitation outlook suite and display and in content, and I'll show a little bit more of what that means in a second. Moving on to the next slide, please. So as I described the information on the left, what I do want to point your attention to on the right is the two difference of the maps with respect to a particular seasonal outlook from August, September, and October of 2021, late last year, of the older version on the top and the bottom version on the bottom, where we applied the recommendations that Mike went through and what was provided. And you can see a number of differences in improvement. I won't go through all of those, but it was generally overall feedback quite positive overall about these changes. Some of the main problems with respect to space, white color, if you will, with respect to clutter, unclear legends, and so on, were improved drastically with this treatment on the difference there on the right. And so, but as far as to make this happen, of course, once the study was done, the team, led by myself, and as I mentioned, the other folks, we wanted to make sure we gained approval first from our management within the CPC Office of Director. So we went through and discussed what we found and what some of the recommendations were. We then introduced and gained support from the CPC staff, including the forecasters, to make sure they understood why these certain things were done and what the benefits were. And within the Weather Service and NOAA in general, within the last 5-10 years, the evidence-based approach of being key with all aspects of the enterprise, whether it be from the science perspective, the outlook generation perspective, or in a case like this, making changes to existing products or creating new products, much more in the realm of providing pretty clear evidence and support for this. The paper that was published helped us in that regard as well, peer-reviewed literature publication. And so in doing all of this, the presentations were again, I mentioned to the Office of Director. I gave a number of presentations to the staff at CPC, and then presented it at the Climate Diagnostics and Predictions Workshop in 2019, where it's a meeting of combined applied research and development and user and stakeholder interaction and decision-making process, all but generally combined. And then during a number of briefings in 2021, I did include some of the new images and some of the briefings to partners and other stakeholders to get a feel from what they thought before we would move towards start the process of implementing this. So if you go to the next slide, the overall process is that we're very fortunate at CPC that we have the Climate Services branch within headquarters that manages the climate program. A lot of great people there have worked with us on many different activities, and they did with this as well. And so we need to work with them very closely so that we understand the steps that are required to be in compliance with the new, not new now, but the National Weather Service Change Protocol for climate services and all weather services in general for the different programs. And I won't go into all the details of that process, but the process and the steps and the overall requirements do depend somewhat on the type and complexity of the change that you're requesting or you're proposing to make. And in addition to that, on the other end, what potential impact to your users this change may produce as part of this protocol and is appropriate. More subtle changes in appearance where you're not adding new content follow a different path or a more quick path, whereas if you're changing content, drastically, or changing the formats of output that you provide to your users take a longer path. So the recommendations from CSB, which was headed at that time by Fiona Horsfall and now Marina Timofeyeva, was that we needed to move forward with some of the details, but also what we required was more of a shorter path, and that we would send that notification to the field and our partners and stakeholders for 30 days, so they're aware of what we're planning on doing. And the comment or review period, if you will, was relatively short because the underlying data that we were producing in these maps, ArcGIS and Google Earth formats, for example, and did not result in major code changes for downstream users. And so, in general, we produced a web page, a prototype, basically, of what we were going to be changing it to for people to view as part of the service change notice, and took comments and feedback that way. Next slide, please. So, from our end, in addition to that, more of the bureaucratic path of getting approval and moving forward with feedback, staff at CP, of course, needed to do some changes with respect to the plumbing or the technical aspect of data staging, dissemination, and of course, web display information. We did move forward and was able to make this operational in relatively short order once we started. And this was on September 16th, 2021, and that was with the week 2 outlooks, the monthly outlooks, and the seasonal outlooks. This past Friday, we were able to implement for the week 3 and 4 outlooks this past Friday, January 7th. But keeping in mind that this is a 2-class system, which is shown, the example that was released this past Friday is shown there on the bottom. If you can go to the next slide, we move forward to the second recommendation, which is a longer horizon type path. As you can see here, it has been noted by others in the past, the recommendation, of course, was the inconsistency in presentation across these products, which I'll go through briefly here, causes confusion and interpretation challenges amongst even our most experienced users. And the recommendation was to make these more consistent, which we certainly agreed with. Again, over the years, we've had a number of challenges with respect to the variation of these types of outlooks. And for example, just running through very quickly on the bottom, you can see on the left-hand side is a week 2 outlook where it's a 3-class system. We have the shading for near normal, that is gray. Above normal, the upper third of the distribution of red or orange, and blue for the lower third of the distribution. We have contour lines that show the daily mean, 5-day mean, in this case, or 7-day mean temperature, and dashed lines there. If you look at the middle plot, this is the week 3 and 4 outlook, which is a 2-class system, so it's already different in that respect. The shading is one color for either above or below the 50th percentile. And we have the white areas in this case are consistent with the longer lead where it's on equal chances. And there were reasons why we made this 2-class and why we displayed it this way. But in the focus groups and in the survey results, those goals were not achieved, and that it would be much better to make this consistent with some of the outlooks. And finally, on the right is the seasonal outlook, which is also a 3-class system, although in this particular example is favoring just above normal temperatures for most of the country in this case. But again, it's 3-class with no climatological lines. And going to the next slide, my final slide, is that this is a longer term, as I mentioned, for the outlook consistency. This is not only a change with respect to the social science recommendations, but also in applied research development, climate change. This STI portfolio has graciously funded project to apply some of that research and then look for the evaluation of converting this from 2-class to 3-class for the week 3 and 4 outlooks as recommended. We have this as an STI milestone and project, and we're in the process now of the project scope, requirements, and deliverables have been outlined to first order, and we're completing the project plan and associated timeline at the current time. And this is a more extensive change. It's more extensive work in the sense that our observations, our forecast guidance products, whether it be the numerical model guidance that we have, also statistical tools and hybrid information, where the dynamical model informs and aids the statistical methodology, all those have to be recast for a 3-class system, meaning the lower third near normal, the middle third, and above normal for the upper third, both in observations and in our forecast guidance products, both in real time and in the retrospective format. And these will all have to be re-evaluated for forecast skill, both in the retrospective or reforecast sense, but also through independent data verification to see what forecast skill is involved with the three classes in order to provide information, quantitative information, as we move up the approval process within the Weather Service before implementing operationally. We plan to complete this process by the end of the fiscal year in October 2022, experimentally, and then move through the process within the Weather Service to see where we stand with the approval process. So I think the final slide is just a thank you, and I guess I will turn it back over to Melissa. Thank you.
Thanks so much, John. It's so exciting to actually see these things go into practice and to see the expansion of evidence-based approaches to improving the accessibility of these graphics for a wider range of people. So what's next? We just kind of wanted to give you a sneak peek of things that we're doing. So one is we're working again with CPC and the National Integrated Drought Information System, NIDIS, on improving the drought and U.S. hazard outlooks. We're just getting started on this project. I know a couple of you on the phone call are tagged in our list of folks we're going to be contacting for focus groups and conversations related to those outlooks. So if you get an email coming your way, please say yes so that we can work to improve the existing graphics as well as some new experimental products that are under development. The other thing is we've been working on a project called the Dashboard for Agricultural Water Use and Nutrient Management. This is an innovative forecasting and risk analysis system. What's super interesting and fabulous about it is it's basically downscaled subseasonal to seasonal forecast where we're able to flip things into indicators that are going to be interesting and relevant at the farm level scale. It's being designed for the Corn Belt. We're about to release our first tool in later this spring, so keep an eye out for it. And the website down at the bottom, dawn.umd.edu, is where you can get the news and get the sneak peek once it's released in the next several weeks. So we're continuing to work on this. I think there's a number of really interesting research questions, both about how you improve existing, we call them static graphics that go into like media or other PowerPoint presentations that are not interactive by a user, so that it improves the understandability of those products for a wide range of people, as well as starting to think about opportunities related to user-controlled graphics and how that helps us to rethink how we design and layer information, as well as I think a number of you all had some initial questions related to accessibility, and that's a really important question, is how we make these accessible for everyone and design these so that no one is more privileged than others in being able to access and use that information. So in a nutshell, if you're thinking about scientific graphics that you design yourself or using scientific information to visualize key messages that you want to share, I want to just nutshell a few things that we've learned over the past decade or so of our work in this space. The first thing is be really clear about your audience and their goals and capabilities, because that's really going to dictate how you need to design your graphics. Secondly, we've designed really differently for scientists who have domain knowledge of a topic versus everyone else. And that includes scientists who are not expert in that field. And when we're really communicating to that wider range of audiences, we want to be really clear about what that key message is and what the bottom line is. You do not want to hide that. You can always layer information and go into more detail, but if you hide the key message, it's unlikely that people will be able to find it. I think the third big piece is, so often we try and get things perfect before we send them out, and it's rare that we're going to get it perfect. We can get it more right by using best practices that have been developed through a range of different social science fields over the years. But with any of these products that are designed for other people, I think you want to think about how we apply iterative design and testing as part of a process to continually improve these graphics so they are more effective at achieving their goals. That means that we're improving the understandability, their ability to be used in decision making, and also figuring out ways of how they can be useful for multiple types of decision. And that means that it's unlikely that one product is going to serve all purposes. And so it might be thinking about how you design a portfolio of products that help to serve different audiences in different ways and translate it in a way that's meaningful and useful for them. And then finally, I think across the findings and the work that we've done with these 3 in-depth studies, it really points to the importance and the power of diagnostic design guidelines as a useful tool for creating more accessible, engaging climate and environmental graphics, especially when it's designed for wide public consumption. And we're really excited to see others take the kinds of methods that we've done and apply these kinds of rigorous control treatment studies to be able to improve things that are being designed for the public. With that, I'd like to thank you all so very much for your time, and especially thank our funders, the NOAA Climate Program Office, the NOAA Climate Prediction Center, and the U.S. Department of Interior's USGS, and turn things back to Amanda for some Q&A.
Great, thank you so much. This was an excellent presentation, and it looks like we have a lot of great questions and comments in the questions box. So I'll get us started. There were a couple of questions about this topic. So how was color blindness incorporated into these 3 case studies to make these fully accessible? And what can we learn from the research on accommodating folks with color blindness?
John, just so you know, you're on mute.
Sorry about that. I know that you, Melissa, you had put in questions with the answers for some of those questions. So I don't know if you want it to go, but basically we did follow the Section 508 compliance with that. And for I think most of our outlooks, we also have line only graphics that accompany these shaded type graphs. So this is something we were definitely aware of. And if you want to comment further, Melissa, please go ahead.
No, I would say that in terms of color blindness, everything that you see as the improved graphics do conform to those standards. I think there are some larger questions related to broader accessibility using screen readers, or questions of how you design for audiences with different levels of technical skills and capabilities. I think there's some opportunities to do a wider range of research. And I think some of the questions related to broader accessibility are ones that we're hoping to dive into in the upcoming years. Our goal with this study is to take something that was working for a smaller group of people and expand that. And I think as we think about that, we're aiming with some of our next things that we have on the horizon, but don't quite have funded yet, that we'll be able to expand that into work that allows for a wider range of people to fully be able to use those kinds of data products.
Great. So moving on to our next question, what are the 2-class and 3-class systems that John has mentioned, and how are they different?
Yeah, so first explain, like the class refers to the number of categories that one may try to predict. For example, for the week 2 forecast, the monthly and seasonal, We try to provide probabilistic information on the odds for any one of three categories, which would be, one would be the below normal category, which would be the bottom 33% of the historical range. What are the odds of your eventual observation, whether it be for the week 2, 1 week period, or for the seasonal period, be in that bottom third of the historical range based on now the 1991 to 2020 climatology. So for the 3-class system, you have the bottom third, the middle third, and the upper third, and that's what's termed as the 3-class system. For the week 3 and 4, we try to do a 2-class system, which would be the same approach, of course, but it would just be you basically have the information. So the lower half of the historical range over that 30-year period for whatever you're particularly forecasting for, and then the upper half. So that's the difference. That would be characterized as 2-class.
And Amanda, just to kind of do a quick build on that, one of the reasons we recommended that was because there were real fundamental misunderstandings of the interpretation of how to contextualize and describe those probabilities when we were working with people who were fairly expert in these climate outlooks. And we suggested the change because if there were problems related with folks who had been using these graphics for more than a decade and describing and interpreting them to other audiences, it was likely to sort of filter down to folks who had less technical expertise.
Great, thank you. So our next question is, are there recommendations for how to show data on maps in which the geographic areas overlap? For example, colors versus textures like stripes, etc.
I guess I can take that one if y'all want. If I think I'm understanding the question correctly, yeah, there is some guidance around using either stippling or some sort of extra variable on top of color to indicate either something that's out of focus if you're thinking about uncertainty or fuzziness. Depending on the application, another good way to do it is to use maps that are side by side and have indicator points, especially if you know there's a specific region that people are going to focus on so that they don't get lost between the two.
Great, thank you. Our next question is, do you have thoughts on how to make this process more agile? It seems like a very long lead time to update graphics, requiring a peer-reviewed journal article to justify the changes.
Well, if I could take a crack at that, initial crack. I didn't mean to imply that any change within the Weather Service requires a journal article or a manuscript. The process can be, as I mentioned in our particular case, I felt like in this example, the process was relatively agile in that we did move forward relatively quickly as we could. The journal article was, just in my mind, to help solidify that we weren't doing this on a whim. We had evidence for this. We took this seriously, and that this is what the recommendations are, and we think this is the best approach at this point. And that was just something else to utilize when we're trying to get approval for this process.
I'd say that, there were a few modifications that actually went through as the research was being done and before the research study was being finalized. So, for example, one of the things that we identified that was a point of confusion was white space was not clearly defined and used in different ways. And one of the things that the climate program, the Climate Prediction Center immediately changed, meaning like within a couple of weeks, was actually changing, I think, near normal to a gray color scheme to be able to eliminate that color confusion. And so there were a few minor modifications that were able to be implemented quite quickly. I think the other thing to keep in mind is you can have a more agile process when you're developing an experimental product. You involve the social scientists from the beginning of the design, and it doesn't have to go through an operational timeline. So for example, the project that we're working on right now, Dawn, the dashboard for agricultural water and nutrients, Mike Gerst and I are collaborators with the entire team of researchers, making sure that the first design of those graphics are already using best practices. And once they're released, we're already going to be starting up some of these testing so that we can tweak and improve it on pretty short order within a few weeks to months, instead of a little bit of a longer time lead that's required for operationalization through the federal system.
Great, thank you. Our next question is, how would you broadly describe the different kinds of end users of these various climate and water or drought outlooks?
Well, I guess I'll go ahead and take the first stab at that. I mean, from our perspective with the climate outlooks, there really is a large spectrum of types of sectors that use these outlooks. For example, when we first started this, Melissa will remember, we gave her all kinds of sectors that we wanted to look at, and she was "You're crazy. This is too. We're never going to be able to do this." So, in this particular study, we targeted agriculture, for example, as one of our main sectors that use these products. The emergency management community, and water resources was a big one, of course. And I think the energy sector was the fourth that we did. And of course, there's other sectors that use our products, but. So I guess that helps explain the kind of the spectrum of types of users or stakeholders that use our outlooks. Of course, the Weather Service regions and local offices use them as heads-up products for what they may be able to expect moving outside of their the first week time period. But also quite a bit of other sectors and other federal agencies we have quite a few deep relationship core partners that use these outlooks: Department of Defense, USDA, FEMA, et cetera. If that helps.
Well, I think, Amanda, I mean, you were part of this study when you were an undergrad student a number of years ago. And I mean, one of the things that was most fun when we were taking a deep dive with the entire team was just kind of discovering all of the places that the outlooks would pop up that we weren't expecting. Like, I got an advertisement in my email for renewing my heating and cooling tune-up that was using the outlooks as an advertising tool. We found they were being used as motivators for bathing suit seasons, or planning, exactly where you would go hiking along the Northwest corridor. And so it was really kind of fascinating to see the breadth of uses for these particular subseasonal and seasonal forecasts. I think one of the things that was particularly interesting about that study, though, is we had worked both with, taking a deep dive into more technical expert users as well as public users. And one of the findings that we didn't have time to go into a lot of detail about was, one of the things we found was that if you could improve the product for public users, it also improved it for more expert users. So better design served everyone. It wasn't that you were lowering the quality for expert users at all. It served everyone. And so that gave us a lot of insight, and it creates a lot of flexibility in how you can test for these different graphics by using public as a proxy for a wider range of user groups.
Great, thank you. So our next question is a little bit broad, but they are asking, how do you deal with uncertainty in designing these visuals?
Well, that's kind of at the crux of why we wanted to take on this project, was just because of the number of instances in which there was confusion. Very often we would see folks at all different levels, expert users perhaps at times, and the general public maybe misusing what the outlook was actually saying. And that really, spurred us on, not in addition to the aesthetics of, generally older type graphics, but the understanding the challenges in the understanding of what the product was saying and how you maybe was feeding into how they were using it and making decisions which was not good. And so the idea was, for example, one of the reasons we tried to make the week 3 and 4-2 class and with just one shading for above or below was that people would tend to want to think that deeper shading for the other two outlooks meant that it was proportionally warmer or colder. That's not what they were saying. There were probabilities of one of those categories increasing, not that it was above normal, but even more hotter if the probability shading was higher. And so that sort of aspect was with the legend being more clear and some of the cluttering and with respect to the wording was reduced such that it's more clear what we're actually saying on the maps. And I think that was one of the findings from the whole project was that to address that and also the consistency issue, that was one of the reasons for that. So what you're asking is a very complex question that could take a long time to answer. Typically, many users don't understand probabilities as well as a deterministic forecast. This way, we want to make sure that the static maps, everyone will always use static maps. You can have all kinds of different dynamic, fancy things on the web page. However, static maps will have a use in presentations and other things. We wanted to make that as clear as possible so that if they wanted more information, they could go to other sources that had more dynamic information to them on our website or other sources. Hope that answers a little bit.
Great. I think we have time for maybe 2 more questions. So the next question is, are there resources available to someone or a group who wants to similarly evaluate the effectiveness of their graphics, including recommended tools / guides for some level of self-led review?
For this question, I hope everyone can see it. I dropped a link to the paper that's behind the NOAA CPC results and specifically a reference to the first table. I think that's a good place to start because that sort of quickly summarizes a lot of the diagnostic guidelines that we used to look at those images. And we found that, you know, for people who are starting new on our team, they're straightforward enough that people pick them up pretty quickly.
Great. And I think this question is kind of along the same lines. Is there a document with fonts, labeling, colors, and other specific suggestions for plots created elsewhere at NOAA that are similar to the CPC forecast, for example? The new CPC seasonal forecast plots are nicer and easier to read, even for experts.
Thank you. And I would say in terms of like, at this point, what we've done is we've worked on a suite of products with a collaborator at NOAA. If you're interested in understanding some of the like best practices that might apply to federal data products that you lead, Mike and I have also just gotten on the phone with people and done consultations to help do tweaks or improvements, because I mean, what we found is you can probably get about 75% there just by using best practices from the social science literature to get that like other bump up and to really empirically know that something's being performed is performing better. That's when we get into control treatment studies to just independently verify whether or not our expert judgment of the best practices that should be applied actually are proven to work better. So I put our email addresses in the chat. I've also put links to the papers, and if you're interested in the slides that we used for this talk, I'll also put them in the chat right now. But feel free to contact us if you have individual questions.
Great, thank you so much. And we'll be sure to send out the recording to everybody who attended today, so everybody will have a copy of that. So thank you all so much again for your great presentations today. This was very exciting to learn about, and we had a lot of great questions that I'm sure I will forward on to all of you. So thank you again, everybody, and have a great day.
Thank you all. Great to see you.